question 3, we're dealing with quartiles and percentiles. We're given a data set with 30 data points, and we want to find certain quartiles and figure out certain percentiles. So let's go ahead and get started. So first, in part A, we want to find the 3 quartiles, Q1, Q2, and Q3, and then use those to find the interquartile range. So to give you guys a recap, how do we find Q1, Q2, and Q3? Well, Q2 is very simple. It's just the median of our entire data set. In other words, Q2 is the middle of our data set. It splits our data set in half. Q1 then is the median of the lower half. So it's the median of all data points less than Q2. Q3 is the opposite. It's the median of all data points greater than the median, greater than Q2. It might help if I draw a picture. So let's say this is the first data point, our minimum, and this is our maximum data point. And let's say this is right in the middle. This is Q2. This is the median value. Splits our data set in half. So there's an equal number of data points above and an equal number of data points below. So Q1 is the median of this lower half of my data. And then Q3 is the median. Imagine this is in the middle. Q3 is the median of my upper half. So you can see that finding these 3 quartiles, splits my data set into quarters. Quarters of equal size with equal numbers of data points in them. Hence, why we call these the quartiles. So now that we've recapped our definitions, let's actually find the quartiles. So now remember, anytime you want to find the median of a data set, it needs to be ordered from smallest to largest. So I've done that already for you. So I've gone ahead and written all these data points from smallest to largest. So now let's find Q2. So to do that, I'm going to cross off data points, 1 from each side, until I get to the data points in the middle. Cross these off. Almost there. And you'll notice that there are actually 2 data points in the middle. And that happens anytime we have an even number of data points in our data set. If you count up, we have 30 data points. So whenever we have an even number of data points, so when we have 2 data points in the middle, to find the median, we simply take the average of those 2. Whoops. So I want to take the average of 100 plus 111, and that is 105.5. So 105.5 is our median, Q2. Okay, now next, let's find Q1. Q1 is the median of all my data points less than 105.5. So let me highlight those. That's everything in this first row. So now let's find the median. I'm going to cross these off. 1 from each side until I get to the one in the middle, which is 70. So my first quartile is 70. To find the third quartile, I take the median of all my data points greater than 105.5. So that is everything in these 2 rows. Find the median. And that is this number, 310. So now I have my 3 sample quartiles. And so lastly, for part A, we can find our interquartile range. Our interquartile range, or IQR, is simply our largest quartile minus our smallest quartile, so Q3 minus Q1. 310 minus 70 is 240. All right, so now we've done part A. Put this in a box. Now, let's go to part B. Whoops. Okay, let's do part B. Part B wants us to calculate the 25th and 75th percentiles. If you notice, 25 is 1/4. So it's equivalent to our first quartile. It's everything in the first quarter. 75th percentile is the boundary of the first 3/4 of my data set, right? So everything 3/4 and below. So that's equivalent to Q3. And so we want to find the 25th and 75th percentiles using our definition of what a percentile is, and then check if they're the same. They give us the same numbers as Q1 and Q3 that we just calculated. So let's go ahead and do that. So first, our formula for finding the kth percentile is we take k times n, our sample size, and divide it by 100. And our sample size here is 30 because we have 30 data points. So to find the kth percentile, I'll take k times 30 divided by 100. Now to find the 25th percentile, I take 25 times 30 divided by 100. This gives me 75. I want to be really, I want to emphasize here that 7.5 is not your final answer. This is, 7.5 is the position of the data point at the 25th percentile. 7.5 is the position of the data point that is at the 25th percentile. So that tells me that the 7.5th data point is the 25th percentile. Now, what does it mean to be in the 7.5th position? Well, it's the same thing as being in the middle, in between, halfway in between the 7th and 8th data point. So 1, 2, 3, 4, 5, 6, 7. These are my 7th and 8th data points. So the 25th percentile is halfway in between my 7th and 8th data points. So my 25th percentile, that data point is 70. So let's find the position of the data point that's at the 75th percentile. So we take 75 times 30 and divide that by 100. You can plug that into your calculator and you get 22.5. So now, that means that the data point that is at the 75th percentile is halfway in between the 22nd and 23rd data point. So let's figure out where those are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 240 and 310 are my 22nd and 23rd data points. So the 75th percentile is what's halfway in between those two. So this is equal to halfway in between 240, and 310, which, if you calculate this gives us an average of 275. So my 75th percentile is 275. So let's check up and see if these are the same as our first and third quartiles that we found in part A. Well, 25th percentile was 70, which is the same as the first quartile that we found, 70. So that checks out. The third quartile that we found was 310, and our 75th percentile was 275. These are different numbers. So let's think about why that happened. So we found, using our definition of the percentile, that the 75th percentile was the data point halfway between the 22nd and the 23rd, which was the data point in between 240 and 310. So using this definition, the percentile definition, that was 275. Now, if we had not found the average and just rounded up to 23, the 23rd position, that would have given us 310, which was exactly the third quartile that we found. So the key point here, what I want you to take away, is simply that sometimes the percentiles and quartiles may not always be the same. They might not always correspond to each other, and the reason that happens is just because of rounding. Okay, so that is part B done. Let's now move to part C. Part C wants us to find the sample 60th and 33rd percentiles, and then it wants us to interpret what these numbers mean. So we'll go back to our definition of what a percentile is to find the position. We take k times 30 over 100. So to find the 60th percentile, I'm going to abbreviate. I take 60 times 30 over 100. And that gives me 18. So the 60th percentile is my 18th data point. And so if I count backwards, my 18th data point in my data set is 155. So my 60th percentile is 155, the 18th data point. Next, let's find the 33rd percentile. So I take 33 times my number of data points divided by 100. If I do this, this will give me 9.9. 9.9, I can round this to 10. And so the 10th data point in my data set, so it's 18th, 17th, 16th, 10. My 10th data point is 88. So my 33rd percentile is 88. So last, let's interpret what it means. If I tell you that the 60th percentile of my data set was 155, what does that mean? So if the 60th percentile of my data set is 155, that means that's the same thing as saying that 60% of my data lies below 155. So in other words, if I take everything less than 155 in my data set, so that is all of these data points, the number of these data points that's 60% of my data. So the 33rd percentile being 88, what that means is that 33% of my data points lie below 88. This is the same idea as your percentile when you took the SAT. So let's say your score report told you that you scored at the 80th percentile on the SAT. What that means is 80% of people scored less than you. Or equivalently, you scored higher than 80% of people. Okay, let's now move to Part D. Part D asks, what is the percentile rank of 16? In other words, at what percentile is the number 16 in our data set? And how do we interpret that? So for Part D, I'll do this up here. To find the percentile rank, I take the number of data points less than 16, and then I divide that by my sample size, and then to get a percentage, I just multiply that by 100. So to find the percentile rank of 16, I count up how many data points are less than 16. So that would be just these two data points, 6 and 15. My total sample size is 30. Multiply that by 100. And you should get, if you plug this into your calculator, let's see, 2 divided by 30 times 100. This is 6.66 repeating, or roughly the 7th percentile. The interpretation of this number, well, it's just like what we said the definition of the percentile was. So I found that 16 would be at the 7th percentile in this data set. So in other words, approximately 7% of data points lie below 16. Lastly, we're going to check the empirical rule. I'm going to copy from up here. Bring this down. Oops. What does the empirical rule say? The empirical rule says that for a bell-shaped distribution, 68% of data points lie within 1 standard deviation of the mean. 95% of data points lie within 2 standard deviations of the mean. 99.7% of data points lie within 3 standard deviations of the mean. So if I want to figure out if the empirical rule is true for this data set, if these three facts are true, I first need to find the mean and standard deviation. So you can calculate the mean using our standard formula, and you'll get that our sample mean is 212.9. If you find the standard deviation, you should get 223.2. So that tells me, that means that 68% of data should lie in the interval 212.9 minus 1 standard deviation So 68% of data should lie between these two numbers. And those two numbers are simply the mean minus 1 standard deviation. The upper bound of my interval is the mean plus 1 standard deviation. If you calculate this out, you should get negative 10.3 to 436.1. The second interval, the empirical rule says that 95% of our data points should lie within this interval, which is the mean 2 standard deviations below the mean. So 2 times 223.2 to 212.9 plus 2 standard deviations. So 2 times 223.2. If I calculate this out, 2 standard deviations below the mean is negative 233.5. Whoops. To 659.3. And similarly, if I calculate this last interval, 3 standard deviations below the mean is 212.9 minus 3 times my standard deviation. If you calculate that, you should get negative 456.7 for your lower bound, and your upper bound should be 882.5. So this is what the empirical rule says my data should look like if I have a bell-shaped curve. Let's verify that that's actually true, or see if it actually is true at all for my data. Oops. So let me take my ordered data set again. So let's find this first interval. So where my upper bound, is 436.1. That is everything in the first 2 rows. If I count that up, that is 26 data points. So within this first interval, (26 out of 30 data points are here, so this percentage is 86.7%. My second interval is negative 233.5. I want to see what percentage of data points are actually in this interval. So that is everything less than 760 here. And so if I count that up, that's 28 out of my 30 data points, which is 93.3% of my data. And then lastly, this last interval, let's see what proportion of my data lies here. So everything between negative 450 and 882.5, that encompasses all my data. And I know that I have 30 data points total. So I know that 100% of my data points lie within this interval. So last, let's see if these proportions are the same as what the empirical rule says should happen if I have a bell-shaped curve. You can see that actually the proportion of data points in each of these 3 intervals is larger than what the empirical rule predicts. So in other words, that tells me that the empirical rule doesn't apply to this data set, and that's most likely because this data is not bell-shaped.